Well, welcome to Shop Adventures number 2. That means we survived Adventures number 1. We first of all want to thank our family and our close friends that have all joined us in this video series, and we appreciate it a lot. Thank you for the comments as well. In this video this week, we're gonna work on an issue that's come up, a problem with the Levin Lathe pulley cover that we thought we could solve by working with Levin, but turned out we kind of have to solve it ourselves. So we're going to share a little bit of how we do that and a little more painting of what's going on around here. Okay, so as we come down to the end of these two paint works being done on the Levin pair of Levin lathes, we decided we could squeeze in a Flume watchmaker's lathe model 53. They're pretty rare. We want to go ahead and get caught up with the enamel paint on that, so we can bring that along behind these two Levins. And we also are going to powder coat a really neat indicator stand. It looks really neat, and I can't wait to share it with you in the coming weeks. So come, join us on our journey, please, will you? Hey, Patrick.
Yeah.
What are we going to do about that Levin Lathe pulley cover?
Oh, yeah. Hey, let me explain. Okay, as you know, we have two Levin Lathe setups. We have an older model and we have a newer model from the 80s. And the problem is with our latest model, which uses these square headstocks, and we actually have two. One uses 3C collets and the other uses 10mm collets, or otherwise known as D collets. And the way it works is the headstock gets mounted right on top of the bed, as so, and then we have a pulley cover that gets mounted right on the back. And the problem is if we look at a typical configuration that Levin sells today, if we look at the catalog over here, you'll see the lathe setup. This looks just like ours, gets mounted on the top of the table. Then below the table you have the motor control, and then there's a motor that's inside this box. So you actually have the belt that runs through the table to the pulley on the motor. And if we go back to our setup over here, so on here we have a little pulley that gets mounted on the spindle, and the belt actually goes through the cover right here, through these slots, goes through the bed, and then through the table. Okay, well, our problem is in our configuration, our motor gets mounted on top of the table in the rear. So in our case, we need to have the belt exit and enter through this cover. As you can see, we have no slot. Okay, but this is only a problem on our 10mm headstock. If you look at our 3C collet headstock cover, you'll notice we have a slot right here.
So what are we going to do about it?
Okay, so what I did was I called Levin thinking, okay, we can just go ahead and order this cover with the slot. Okay, but what surprised me was they told me they only stock the covers without the slot because that's their common configuration. And if a customer such as ourselves wants this cover with a slot, we have to purchase this cover and then pay for machining time for them to mill the slot, which can get pretty expensive. So they actually advised us, if we have a milling machine, to go ahead and try milling it ourselves. And after thinking about it, you know, considering that we have one already with the slot, I figured, well, let's give it a try and see if we can just copy this one. So that's what we're going to do. Okay, using SolidWorks, I drew only the main features of the pulley cover, including the slot that will be used for the belt. Now if I enable CAM, we can see the tool paths that will be used for milling the slot, which I've chosen to be very conservative since we're only milling a single slot and we aren't making production parts. For the tool, we'll be using a 4-flute 30,000th radius end mill so that we get nice radius corners and not sharp corners as we see in the drawing right here. Now I'll run the simulation so that we can see the full milling operation for the slot. You'll notice at the very end we take a final pass on both the wall and floor of the slot so we get a nice clean finish. Now we are ready to mill the part. This is our little tag bent milling machine, and it's CNC based. And this is what we're going to use to mill the slot in our Levin pulley cover. And how we're going to hold it is we have this little plate here, and we're going to use these little mighty bites. The little clamps, as you tighten them down, they tighten on the part. So we'll place the cover right here. Make sure it's fully seated. And as I turn these, you can see how they apply pressure to the part. Okay, and now it's very secure. And now we're ready to start milling. What are you working on, buddy?
Uh-oh, hello. Okay. I'm working on a 1930s drill press, and this is the main spindle. And we're going to machine 2 new oil impregnated bronze bushings. And this is the base for it, and this is another part for it, and there's some other parts. And it's going to get a nice beautiful paint job and some new bushings, and it's going to go. So that's what I'm working on today, using 400 grit sandpaper to just get it ready. Okay, well, we've been doing this since 1993, so we're hoping you'll come along and join us on this journey. And please click the link below to learn a lot more about the two of us. So I hope you'll join us on this series, and if you like it, click to subscribe. But I'd wait and see if you like that first video, and a lot of our videos are going to look like these. And it'll probably progress well over time. So join us, would you?